When we're talking about slope, generally we're talking about how steep something is. So if we had to give a real quick definition of slope, it's something steepness. So if you take a look at a couple of real quick pictures here, imagine yourself walking along a hill here. And so you're walking along at this point on the hill, and it's pretty steep, but when you get up here near the top, it kind of flattens out and it's a lot less steep. So if we're going to talk about how steep something is, how are we going to represent this slope or steepness of curve? Now this is a tough question because it depends on where you're standing on this hill as to what the slope's going to be, right? Because if you move places, it's going to be more or less steep. However, if you were walking along this hill, there you are and there you are a little bit later, you notice no matter where you're standing on this hill, the slope is exactly the same. So in a case like this, if we're trying to find the slope of a line, it's very easy to do. All you gotta do is find the slope anywhere, and that's the slope everywhere because it's the same everywhere or it's a constant. This is a harder question, and we'll answer this when we get to calculus. It's actually not that hard to do. We just haven't got there yet. So how are we going to talk about the slope of a line in this case? Well, the definition that most of you probably already know, we're going to do the ratio of how much you go up compared to how much you go over. So we generally kind of draw it kind of like this, a rise over run here. So this part of this kind of triangle tells us how much we went up, and this one tells us how much we went over. So when we're talking about rise over run, that'll tell us how steep something is. Now you would expect the bigger the number, the steeper something is, and the smaller number, the more flat that it is. So the way that we're going to do this, let's take a look at kind of two random points. I'm just going to put two dots up here and connect the dots. Let's label these using some arbitrary values. Let's call this point the first point, so x1, y1. This point the second point, x2, y2. Now don't get the subscripts fool you. All the subscripts you're doing is saying this point is different than that one. That's one point, that's a different point. That's all they are. So if I'm going to try to figure out the slope of this line, I want to figure out how much I have to rise, and I'm going to divide that by how much we have to run. Now visually speaking, I think we can see run a little bit better, so that's the one I'm going to do first. Now the question is, how far did I go to get from here to here? So this x value is x1, this x value over here is x2. So how far is it from here to here? Well, that looks confusing until you think about it. Those things are just numbers, right? If I said how far is it from 4 to 7, well, the answer is 3, right? Because 7 minus 4 is 3. We do the same thing here. So this distance from there to there is this distance, or that x value minus this x value. So it's x2 minus x1. Now rise works the same way, just kind of turned on its side. The y value for the first point is y1, for the second point is y2. So how far is it from there to there? Well, same thing turned on its side. This would be y2 minus y1. So by writing the points generically like this and not actually putting values in here, what we've done is we created a formula to help us find the slope of a line. So what we got is the formula to find the slope of a line given 2 points on the line. Okay, so that's the formula we just had. Now we generally use a symbol for slope, and the symbol we normally use is, oddly enough, the letter M. So it's be y2 minus y1 all over x2 minus x1. All right, so as of right now, you need to memorize this, but it is just a formula. So let's see if we can put it to use. Let's see if I said, find the equation, find the slope of the line that, let's say, passes through -2, 3, and 5, -8. Okay, so since the problem started out with find the slope, and we are given 2 points here, we know we're going to use this formula. Now, anytime in the future, from now until the end of time, if you're going to use a math formula, write it down every single time. It's y1 over x2 minus x1. A couple really good reasons you want to do this. One, you have to memorize this formula, so writing it down every time is going to help you memorize it. And two, we make far fewer mistakes plugging into a formula when we're looking at it compared to trying to do it off the top of our head. All right, now there's one more trick I want you to do when you're doing a problem like this. Above the points or below them, I don't care where you do it, label them, and I don't care which point you call which. Call one of them x1, y1, the other one x2, y2. This keeps a very silly mistake from happening when we go to plug in the points. All right, so what do we get here when I plug them in? That's going to be -8 minus, right, that's y2, minus y1 is 3, all over x2 is 5, minus x1 is -2. All right, so from here, all we have left is just a little bit of algebra. On the top, those are just both negative, so we add them together and keep the sign. Here on the bottom, we have minus and negative, so we have to rewrite that as a plus first. So it ends up being 5 plus 2. So the slope of the line that passes through these 2 points is -11/7. All right, so anytime you're told to find the slope of a line, all you gotta do is plug it into your formula. Now, just for some terminology's sake, in case you hear this in the future, a lot of times a textbook or a teacher will call this the change in y over the change in x. It's just another way of saying the exact same thing. All right, so finding the slope of the line is pretty easy. We're going to use our formula. Let's talk about a few, I don't know what to call this. How about just facts about slope? So I'm going to draw a bunch of pictures here for us. Let's see if we can do this. There's our axes. There's our x and y axis. If we have a line that looks something like this, now I don't have anything labeled, so we can't say anything specifically about the slope, like I have no idea what the slope of this line is, except for, I can say that has a positive slope. How do I know it has a positive slope? Well, think about it. If you pick a point, I don't know, randomly over here and over here, how do I get from this point to that point? Well, you'd have to go in a positive x direction and a positive y direction. So a positive over a positive would be a positive. So if we had something like this, I know you can figure out what the next picture is going to be. Something that looks like this, this would be a negative slope. Now how do I know that it's negative? Again, just take 2 points on the line. So if we move over, notice to get from here to here, we'd still go in a positive direction in the x value, but we'd have to go down or in the negative direction in the y. So a negative divided by a positive is a negative. All right, so just by looking at a graph, you can actually tell without any other information than just the line itself, whether or not it has a positive slope or a negative slope. Let's do these. Let's take a look at our 2 special lines. You have a horizontal line, right? Again, act like that's a horizontal line. Well, you'd have rise over run. Well, since this thing doesn't rise at all, that's basically a 0. So you have no rise and you can run as much as you want, but 0 divided by anything is 0. And this should work intuitively, right? Because how much slope or how steep is a horizontal line? It's not, right? So this has what we say 0 slope. Next one's quite a bit more complicated. We'll go through this. This would be a vertical line. All right, we're going to do a little bit of side work here before we can get this. I know some of you know the answer to this and you're saying in your head right now, oh, the slope's undefined. Well, the problem is with that is a lot of us don't really understand what that means. If I walked up to you right now and I said, what does undefined mean? Some of you might say, well, it's not defined. Okay, then my next question would be, what does defined mean? Now, defined just means it has a specific value. Think about it like this. I have 1 pen in my hand, right? So 1 is a defined quantity because I can show you 1 pen. 2 is a defined quantity because I can show you 2 pens. A billion's a defined quantity because I can pile up a billion pens and go, hey, look, there's a billion pens. Something like infinity, though, that's not a defined value, right? Can I pile up an infinite number of pens and go, there's an infinite number of pens? No, you can't. So that doesn't have a defined value. So how does that work into this? Well, let's take a look at a couple of lines. Now, back from your old geometry days, you may have seen this. These are just kind of lowercase cursive L's. We generally use this in geometry to show lines. So this is line 1 and line 2. So if we try to compare the slopes of these two, again, I don't know what they are, but since line 2 is steeper, I could say the slope for line 2 is a bigger value than the slope for line 1. And I could continue to do this for most of the day by making the line steeper and steeper and steeper, right? So L3 is steeper than these two, which means the slope for line 3 is bigger than the slope for line 1 and for line 2 down here. Now I can keep doing this all day until I get to, I'm gonna try, a vertical line, right? I can keep making it steep. Now if I go any farther, I'm actually making it less steep, just in a negative kind of direction here. So this line right here is steeper than any other line that I could possibly draw, which means the numeric value of this line has to be bigger than any other possible number. Well, the only thing that's bigger than all the numbers is infinity. So technically, a vertical line has an infinite amount of slope. It can't have any more slope, right? That's as steep as you possibly can get. Now, we don't say that a vertical line has an infinite amount of slope. We just say that its slope is undefined. Right? So there's kind of your link between infinity and undefined, right? Because it's not a defined quantity. All right, let's take a look at 2 more things here real quick. What if we have parallel lines? Well, this one should be easy, right? If 2 lines are parallel, that means that they never touch or they never bump into each other. And just for a little bit, you don't really need to know this, but it's going to be helpful here in just a minute or two. The notation for parallel lines is you put kind of like 2 absolute values really close to each other. So from geometry, this says that line 1 is parallel to line 2. And of course, they would have to have the same slope. We take a look at perpendicular lines. Well, this one's a little bit harder to see. By the way, the notation for this. So line 1 is perpendicular to line 2. It's a capital upside down T. All right, it's really hard to see from a picture like this, but you can kind of get the idea. Would you agree to be perpendicular? Again, it just means meet at 90 degrees. That if one's going up or has a positive slope, the other one has to have a negative slope. So the signs of 2 perpendicular lines have to have opposite signs. Also, and you'll probably see this a little bit better if you look at your textbook, if you draw little rise over run triangles, you can kind of see that they're switched. The amount that this one runs is the amount that that one rises, and the amount that this one rises is the amount that this one runs. Well, if you switch the rise and run, basically all you're doing is flipping over a fraction. Well, that's just called the reciprocal. So perpendicular lines have negative reciprocal slopes. All right, so how is this useful? Let's take a second and do a very quick table. And we're going to use some notation that's not in your book. So this might be a little bit confusing. We're going to have 3 columns here. We're going to have the slope. And then as a subscript, I know it looks like an 11. This is going to be the parallel slope. And then the subscript for this is our perpendicular. That's going to be the perpendicular slope. So I'm going to give you a slope, say 2/3. And then I'm going to ask you what is the parallel slope and what is the perpendicular slope, right? So parallel has the same slope, so that's 2/3. Perpendicular is the negative reciprocal. Now the easiest way to think about that is just flip it over and change the sign. So if I flip over 2/3, I get 3/2. This one's positive, which means this one has to be negative. All right, so I'm going to give you a couple here. 4/5, 6, -1/3, and 0. All right, do me a favor, hit pause real quick and see if you can finish filling out these tables. So for each one of these slopes, give me the parallel slope and the perpendicular slope. So hit pause and come back when you're done. All right, guessing you're back, let's give it a shot. So for -4/5, of course, the parallel slope is exactly the same. Perpendicular slope says flip it over, that's 5/4, and change the sign. This one's negative, so this one is positive. All right, so for the 6, of course, the parallel slope's exactly the same. Now remember, to flip that over, we got to put the 1 on the bottom, so that's going to be 1/6. This one's positive, so that one has to be negative. -1/3, the parallel slope would be the same, -1/3. Perpendicular slope, flip it over, so we get 3/1, or you can just write 3 if you want to. This one's negative, so this one has to be positive. All right, so for 0, the parallel slope is also 0. Now, I'm guessing if you made a mistake on the table, you have a 0 right here. That's the most common mistake. But since that's a whole number, you got to do the same thing we did for the 6 up here. You got to put it over 1. You flip that over, and that's 1/0. Now remember, 1/0 is undefined. Right. This should make sense about these two, because we're talking about perpendicular lines. What type of line has a slope of 0? Well, that was right here, right? That's our horizontal line. And what type of line has a undefined slope? Well, that's a vertical line. And a horizontal and a vertical line are perpendicular. So the idea of how to find parallel slopes and perpendicular slopes given a slope is something we're going to see in the future. So make sure you go through this and you understand it.